For this first problem, we set it equal to 0, and we subtract the 48 to the other side. So we get x squared plus 16x, and I'm going to leave a space, equals negative 48. Okay. Now, we want to create a perfect square. So this is going to be x with something in here to the second power. What number goes inside this factor? It's half of 16. So positive 8. And then what do I do to this 8 to find my perfect square? Times it by itself. So 8 times 8 is 64, so we put plus 64. Well, if I have a balance and I randomly add 64 pounds to one side, now it's no longer an equal sign. So I need to add 64 to the other side so that it will go back into balance. So plus 64. That's just how you complete the square. Yeah, that's just the method. Move the 48 over, cut it in half, square it, add it to both sides. What is negative 48 plus 64? 16. So now I have x plus 8 squared equals 16, so I can take the square root. Anytime you take the square root of a variable to the second, you get plus or minus. What is the square root of 16? 4. Now I'm going to subtract 8. So I get x equals negative 8 plus or minus 4. So there are two answers here. What is negative 8 plus 4? Negative 4. What is negative 8 minus 4? Negative 12. And those are my two roots. So that's where the graph crosses the x-axis. Could I have factored this one? Well, it would have been x plus 4 times x plus 12. And then when we change them, we would have got the same answers. So I could have taken the original and turned it into x plus 4 and x plus 12. And then those are going to give me the same roots. But if the quadratic doesn't factor, we have no way to find the answer, except completing the square will do that. So that's why we complete the square. That's why we created this strange system to find the roots. If it factored, it would have been easier just to factor it. But if it doesn't factor, you have to complete the square. All right, for the second one, I'm going to move the 15 to the other side, and I get x squared plus 10x. I leave a space, equals positive 15. Okay, so what goes in my factor? Half of 10, and the 10 is positive, so it's a plus 5. If 5 is my factor, what is my perfect square? 25. So I add 25 to both sides, and I get x plus 5 squared equals 40. This time when I take the square root, 40 is not a perfect square. So I square root this, and I square root this, and I get x plus 5 equals plus or minus. Well, 40 doesn't come out evenly, so I just need to simplify it. What goes into 40? 20 and 2. What goes into 20? 10 and 2, and 5 and 2. Can I bring anything out? I can bring out a set of 2's, and what's left? The 5 and a 2. So what's on the outside? 2 root 10. Does anybody not understand that? Everybody good? Okay. Now I'm going to subtract 5. Well, you cannot put square roots and rational numbers together. We always put the square root last, so my answers are x equals negative 5 plus or minus 2 root 10. So if I would have tried to factor this, x minus an x plus, are there factors of 15 that add to be 10? 1 and 15 and 3 and 5. Do I get a 10? No. So this doesn't work. So you have to complete the square to find out what the roots are. And we could find the decimals for this. If you took your calculator and you typed in negative 5 plus 2 square root of 10. Oops. Negative 5 plus 2 root. Sorry. 2 square roots of 10. So one of them is 1.32. And the other decimal would be 11.32. That's where that graph crosses the x-axis. All right, let's do the last one. Move the 18 over. X squared minus 2x equals negative 18. What is my factor? Half of negative 2, which is negative 1. And I take that to the second power. What's negative 1 times negative 1? 1. So I add 1 here and I add 1 here. Negative 18 plus 1 is negative 17. So I take the square root. What are the factors of 17? It's prime, so it doesn't simplify. So I get x minus 1 equals plus or minus. I can do something to that. I plus or minus I root 17. Now we add 1 to both sides, and we get x equals 1 plus or minus I root 17. The 1 came from here. So this graph actually misses the x-axis entirely. If we would have tried to factor it, we would have got no solution. And if you graph it, it misses the x-axis, which means that the roots are imaginary. Pull out your worksheet from yesterday. How far did we make it? I don't remember. Can I see this? So how far? You only had to do to number 3? It's in the box. It's complete the square, and it's not honors. So there's a complete the square honors and a just complete the square. Okay, so turn to page 2. I don't know if I have one. So if you look at page 2, it's near the bottom, Robbie. Is this, did we do this one? No? Okay, that's where we'll start. So this time we have a 2x squared, which is a problem. So I need to divide everything by 2. Is that going to change the graph? Yeah. Is it going to change my roots? No. You're allowed to divide by 2 as long as you're just looking for the roots. So I get x squared plus 8x plus 8, but I'm going to move that second 8 to the other side and get negative 8. Okay? So what is my factor? X plus 4. And if my factor is plus 4, what is my perfect square? Plus 16. So this is x plus 4 squared equals negative 8 plus 16 is just 8. Now I take the square root. X plus 4 equals plus or minus is 8. Can you take the square root of 8? No. So I need to factor it. So, oh, look, there's an 8. 4 times 2, 2 times 2. Do I have any pairs? I have a pair of 2s. Anything left over? I have a 2 left over. What about this 4? It's not prime, so we throw it out. So x plus 4 equals plus or minus. I bring out a 2, and I leave in a 2. And now when I subtract 4 to the other side, I get x equals negative 4 plus or minus 2 roots of 2. That wasn't too bad, was it? Okay, now I think your problems are different from mine. Can I borrow this? Thanks. All right, what should we do on the next one? Divide by 4. X squared minus 3x minus 12. This one is a little bit harder. So, x minus 3x, leave a space, equals 12. What goes in my factor? 1.5, but you don't want to use the decimals. You always want to use the fraction when you complete the square. If you use the decimals, every once in a while it will work out to be a nice number, but most of the time when you use the decimals, you'll get the wrong answer. Well, it'll be correct, but it won't be the answer you're looking for on like the ACT or something on the core test. So what I want you to do is just minus 3 over 2. The fraction is 3 over 2. The decimal is 1.5 because it's 3, and we're going to cut it in half. So 3 over 2, right? The number that goes in the parentheses is always half of the middle number. So half of negative 3 is negative 3 over 2. So what goes here? Well, what is 3 times 3? 9, so plus 9. What is 2 times 2? 4, so 9 over 4. So you just take the fraction and multiply the top by itself and the bottom by itself. Okay? So if I add 9/4 to one side, I want to add 9/4 to the other side, and I don't know what 12 plus 9/4 is, so I just use my calculator. 12 plus 9 over 4, and then I push the math button, and the first one in the math button says answer fraction. So I want to turn my answer to a fraction, which is 57 over 4. Did you not get that? Did I do it wrong? Oh, okay. So this equals 57 over 4. Now I take the square root. And I get x minus 3 over 2 equals plus or minus. What goes into 57? 3. What's 57 divided by 3? Reagan, do you want to hit that? 57 over 3. What is it? 19. Does 19 factor any further? So if I have a 3 and a 19, can I pull anything out? No. So plus or minus the square root of 57 over, what's the square root of 4? 2. Okay. So now I add 3 over 2, and I get x equals 3 over 2 plus or minus root 57 over 2. And this is always going to happen in a case like this. Notice they both are divided by 2. When they're both divided by 2, we combine the tops and we combine the bottoms, and we get 3 plus or minus root 57, and we just divide everything by 2. And that's what it's going to look like. And that's as tough as these get. Okay, so let's do a couple more. Look at the next problem. X plus 5 minus 14. Am I going to need fractions in this case? Yes, because the middle number is odd. So I add the 14 over here. Get rid of this. So x plus, what goes in my factor? Half of 5, so it's just 5 over 2 to the second. Well, what is 5 over 2 times 5 over 2? 25 over 4. So 5 times 5 is 25. 2 times 2 is 4. So I add 25 over 4. So in my calculator, 14 plus 25 over 4, fraction 81 over 4. Okay? Square root, square root, square root. What is the square root of 81? 9. So x plus 5 over 2 equals 9 over 2. I forgot something. Do I need an I? Plus or minus, right. I don't need an I because they were both positive. Okay? So now I subtract 5 halves, and I get x equals negative 5 over 2 plus or minus 9 over 2. Well, these are going to simplify. So negative 5 over 2 plus 9 over 2 is 2. So my first answer is x equals 2. How do I calculate the second one? How do I find the second answer? So negative 5 over 2 minus 9 over 2, which is negative 7. So this graph crosses the x-axis at 2 and at negative 7. All right. Let's work the next one. Move the 16 over. What number goes in my factor? No, half of the middle term. Half of 7 is 7 over 2. So this is plus 7 over 2 equals, so what number do I put here? What is 7 over 2 times 7 over 2? 49 over 4. Plus 49 over 4. So 16 plus 49 over 4, math fraction, is 113 over 4. So this is 113 over 4. What's my next step? Take the square root. X plus 7 over 2. What goes into 113? Try, does 7 go into it? What about 13? Nope. Okay, it's prime. 113 is prime, so this equals plus or minus the square root of 113 over, what's the square root of 4? 2. Now I subtract 7 halves and subtract 7 halves. So x equals negative 7 plus or minus root 113 over 2. All right, I want to work one more problem with you. Borrow somebody's worksheet. Let's do number 4. Number 4. Set it equal to 0. Add 28 to the other side. X squared minus 3x. Leave a space. Equals 28. Okay. What goes in my factor? Half of 3. Half of 3 is just 3 over 2. No, the I is when you get a negative on the other side. So 3 over 2 times 3 over 2 is 9 over 4 plus 9 over 4. Okay, so in my calculator, 28 plus 9/4 is 121 over 4. 121 over 4. What's my next step? Take the square root. Take the square root. X minus 3 over 2 equals, what's the square root of 121? 11, and the square root of 4 is 2, so this is plus or minus 11 over 2. So I add 3 over 2 to the other side. Add 3 over 2. My first answer is just 11 over 2 plus 3 over 2, which is 7. My second answer is negative 11 over 2 plus 3 over 2, which is going to be negative 4. So this graph crosses the x-axis at 7 and at negative 4. Okay, I want you to work on the rest of this assignment. We have a lot of time. I'm here to help you. This will be due tomorrow.